So good morning, students. Today we're going to discuss, very important properties of superconductivity. I mean, you can able to see here a lot of applications, really wonderful applications. I guess are you able to see this slide? Yeah.
Yes, sir.
So, what do you think here? Like really wonderful, applications. The first application you can see here. This one is like application of magnetic, like levitation. Trains, they're going like anything, and the speed you can see how fast they are going. So, like bullet train applications, like it's a toy, but it's kind of like showing the basic experiment here. On the right side also you can see all this is actually magnetic levitation. See, it's like air. It's not even falling down. It's wonderful, right? When we have already discussed it, there is a force which is actually acting on it, which does not allow to contact that. I mean, being a magnetic material like diamagnetic material, they oppose whenever the superconducting it comes whenever it comes to the superconducting state, the field line does not allow to enter into the sample. As we have seen that the field line should go away from it, expel it. The field line, the bottom one is actually, let me show here what is going on. The bottom one you can think about, this is the magnetic material, diamagnetic material, or maybe magnets. Think about this is a magnetic material, completely ferromagnetic material. And the top one is superconducting material. So you are placing the superconducting material in the presence of magnetic field. So the magnetic field they do not enter into the superconducting material. They expel the field lines, the field expel out of the sample, out of the material. So that is the reason it doesn't it always away from the magnet. Okay, so which is really wonderful actually. Uh, we can go like anything. The speed you can see how we can use this principle in making the bullet trains, in making the levitation. Like it goes like 500 600 kilometers per hour, which is really wonderful applications. So here also you can see in the bottom line, see the field lines are when it sees the superconducting material, they don't enter inside. The field lines go away from it. Same principle is here. It doesn't touch it. It's a wonderful application. Are you following me? Are you guys? I mean, did you understand? Did you understand this? And I
Yes,
said
sir.
magnet కింద ఉంది, మ్యాగ్నెటిక్ మెటీరియల్ కింద ఉంది, పైన సూపర్ కండక్టింగ్ మెటీరియల్ ఉంది. సో మ్యాగ్నెటిక్ మెటీరియల్ నుంచి వచ్చినటువంటి మ్యాగ్నెటిక్ లైన్స్ అనేటివి అవి ఎప్పుడైతే సూపర్ కండక్టర్ని చూస్తాయో దాని దగ్గరికి ఉండి వెళ్ళవు. అప్పుడు ఆ ఫోర్స్ వల్ల అది లిఫ్ట్ అయిపోతుంది, పైకి లెవిటేషన్ అవుతుంది. దట్ ఈస్ ద ప్రిన్సిపల్. ఓకే, moving into as I already just now I discussed the magnetic levitation or maglev or magnetic suspension is the method. Magnetic suspension is the method you can see here, is the method by which an object is suspended with no support. Wonderful. With no support other than the magnetic fields. So here it's a magnetic field. Here there is no support. Okay. So magnetic levitation is a method by which an object suspended means with no support other than the magnetic fields. So magnetic force is used. Magnetic force is used to counteract or interact with the effect of gravitational field, any other axis. So basically the magnetic force is much more higher than the gravitational field. Okay, the two primary issues, as I already discussed, lifting force and stability, these two are the important factor to understand here. Okay, So now you understand if someone asks you what is a magnetic levitation, you should be able to know that. So we place the magnetic material down and we place the superconducting material over there, and this magnetic force is much more higher than the gravitational force. This superconducting material is it just it's just like a flies in the air without any support. Okay, so I'm going to uh, clear it. You just need to understand this. Yeah, Misner effect, same thing, like Misner effect. Whenever you have a levitation, so that's like a yeah, bullet train, as I mentioned already. So this is the one of the application. Electromagnetic, electrodynamic, electromagnetic, electromagnet application also we start to separate the metals from the waste stuff like trash. So that is also useful, and bullet trains also you can see here how it works. This is also very important 4 marks bit. What is the Josephson effect? What is the Josephson effect? So now you need to understand what is the Josephson effect. Okay, it's very simple, beta. I'm showing here. I'm showing very easy manner. This is a superconductor 1. This is a superconductor 2. I am filling a little bit layer between the 1 and 2. I am placing a one insulator, I would say, one insulator between the superconductor 1 and 2. And there is a chance of tunnel of electrons from here 1 and 1 to 2. So electron can move from 1 to 2. Even there is a barrier. Even there is a they tunnel. Tunnel means like they pass through this material. Did you understand? So when you can two semiconductors separated by a thin strip of no, it's installer, no, it's an insulator, form a Josephson junction. Very important bit, beta. What is the Josephson junction? When two semiconductors are separated by a very thin strip of insulator, form a Josephson junction. Okay. Now you understand what is a Josephson junction? When two semiconductors, how many? Two semiconductors are separated by a thin strip of insulator is called Josephson. What is going on here? Wave nature of moving particle makes electron to tunnel through the barrier. అంటే ఈ దీని గుండా వెళ్ళిపోతాయి అన్నట్టు ఎలక్ట్రాన్స్ దీని గుండా వెళ్ళిపోయి 1 నుంచి 2 కి వెళ్ళిపోతాయి. దట్ ఈస్ టన్నలింగ్ అంటారు. దే టన్నల్ త్రూ దట్. So consequence of tunneling electrons across the insulator, there is a net current across the junction. This is called DC Josephson effect. What is called? DC Josephson effect. The current flow even absence of the potential difference. Is it clear? Very, very important 4 marks break. So the two superconductors are separated by a thin strip of insulator, okay, form a Josephson junction, okay, and the wave nature of moving particles like electrons can tunnel through the superconductor 1 to 2 via this junction, and there is a net current across this junction, which is actually DC Josephson effect, and this is occurring in the absence of potential difference. Okay, the magnitude of current, this whatever current in this junction depends on thickness of insulators which you place here, or nature of material, or temperature. So very important, the magnitude of current through the Josephson junction depends on what are the factors. Number 1, thickness. Number 2, nature of material. Number 3, temperature. These three parameters, very conceptual questions, competitive examiners they're going to ask. DC, what is a DC Josephson effect? DC Josephson effect, when you place a thin layer of insulator between the two superconductor, there is a junction formed which is Josephson junction. When there is an electron tunnel from one superconductor 1 to 2, there is a net current across the junction, which is actually a DC Josephson effect, which depends on several factors: thickness, nature of material, temperature. On the other hand, with the potential, when potential difference is applied, the two sides of junction, there will be oscillating tunneling current. This is called AC Josephson effect. Very important, beta. Very, very important. What is the difference between the AC and DC Josephson effect? Very, very important bit. All job interviews, when you attend the scientist interviews, DRDO, DRLM, DMRL, the main question they're going to ask, what is a superconductor? Oh, I know, sir. The material which shows the sudden, drop and where you have the resistivity 0. And what is the transition temperature? Sir, I know, sir. Transition temperature is the temperature where it just convert into the normal conductor to the superconductor, and where the resistivity drops 0. And what is the transition magnetic field? The same, sir. The magnetic field is a transition magnetic field is a field where the normal conductor behaves like a superconductor. And what is the Josephson effect? Josephson effect, very easy, sir. It's like, you need a two superconductor, and which should be separated by the insulator. And when you join together, and there is electrons tunnel from one side to other side through the junction, and there is a without potential difference, that is called DC Josephson effect. When you apply the potential difference, that is AC Josephson effect. I guess you understand. Is it clear, please?
Yes, sir.
Did you understand, please? అర్థమైందా నాన్న? Hello, are you guys listening or just did you understand?
Yes, sir.
Yes, sir అంటే కాదే బాబు, అర్థమైందా? నా హెడ్ పోతుంది అసలు ఇక్కడ, నీకు అర్థమవుతుంది కానీ ఏమి? Did you understand? Are you guys are there? సుష్మా, స్వప్న, అర్థం కాకపోతే అర్థం కానిలేమ్మా, చెప్పమ్మా. జోసెఫ్సన్ అంటే ఏం చేసిండు చెప్పండి, చెప్పండి.
సూపర్ కండక్టర్స్ తీసుకొని,
టూ సూపర్ కండక్టర్స్ తీసుకొని మధ్యలో ఒక లేయర్ ని పెట్టాడు.
ఎస్ సార్.
దెన్ ఏమైంది, ఇక్కడ ఉన్న ఎలక్ట్రాన్స్ ఇక్కడికి వెళ్ళాయి ఈ జంక్షన్ ద్వారా. అప్పుడు వచ్చిన కరెంటే పొటెన్షియల్ డిఫరెన్స్ లేదు కాబట్టి అప్పుడు వచ్చిన డిసి జోసెఫ్సన్ ఎఫెక్ట్. డిసి జోసెఫ్సన్ ఎఫెక్ట్ అంటారు దాన్ని. ఏసీ కావాలంటే ఏం చేస్తాము, యూ అప్లై ద పొటెన్షియల్ డిఫరెన్స్, అంటే దాన్ని బ్యాటరీ కనెక్ట్ చేయాలి, అప్పుడు వచ్చేది ఏసీ ఎఫెక్ట్. ఈ దేని మీద డిపెండ్ అవుతుంది జోసెఫ్సన్ ఎఫెక్ట్? టెల్ మీ హౌ మెనీ ఫ్యాక్టర్స్ ఇట్ డిపెండ్స్. whatever the current generated across this junction depends on thickness of insulator which you keep, nature of material, and temperature. Understand?
Yes, sir.
amma babu enta revision chesina meeku sare మీ లెవెల్ ఎట్లుందో నాకు తెలియదు. సో ఇక్కడ చూడండి జోసెఫ్సన్ ఎఫెక్ట్ డివైస్ ఎట్లుందో చూస్తున్నారా? did you see that?
Yes, sir.
So 1, 2, this is the junction, and the electrons go from here to here, and the net current should produce DC. And when you apply this potential difference, you get the AC. Without this, you get DC. With this, you get AC. See, students are really bad. They don't want to join. It's okay. I just want to finish it. Okay. So same current tunneling effect, insulator, just same thing, whatever. So there is one more last topic of this unit, not unit, superconductor. London penetration depth, a London equation. London equation. Very important. 4 marks. 4 marks. What is the London equation and what is the penetration depth? So, as you know that type 2 superconductor నేర్చుకున్నాం కదా? నేర్చుకున్నామా? Did we complete it?
Yes, sir.
So we completed the type 2 superconductor. So what are they? Type 2 superconductor resistivity suddenly zero avadu kada. It's like a tunnel, right? So type 2, type 1, we know that type 2 superconductor having the higher magnetic field, the higher application, lot of applications there. And type 2 kind of like a back, it's like, you know, penetrating. It's not a, it's a mixed state. Type 2 low superconductor state and normal state, both are there. Okay. And London is the famous scientist who was working about the superconductivity. And he did an experiment. So the experiment had shown that only magnetic field is zero, but also B zero within the superconductor. ఎందుకంటే సూపర్ కండక్టర్ గుండా మనకు ఫీల్డ్ లైన్ ఇలా వెళ్ళిపోతాయి. సో ఈ మెటీరియల్ గుండా వెళ్ళవు. సో దే గో త్రూ లైక్ దిస్. సో inside B is equal to 0, right? Outside not equal to 0. So within the superconductor magnetic field is 0. So according to London, he suggested that not only this, B square, delta B square by B equal to B dot dou B by dou T. So 1 by alpha. Okay. So dB by dt. So this is what he did equation. This is what he did it. And this equation, you should remember that. So this is not equal. You don't need delta square B equal to dou B by dou T. Okay. No, this is not actually B dot only. No, let me say delta square B is equal to dou square B by dou T square. Yes, this is right actually. B dot actually, this is B dot. B dot actually, but this double dot you have to keep. So this is actually London equation. Del square B equal to dou square B by dou. This is actually London equation. For this actually solution is this. Bx is equal to Ba exponential e power minus x by lambda, where lambda is actually London penetration depth. Lambda is a penetration depth. So in type superconductors only they can have the penetration depth. It is a fundamental length scale of the superconducting state. Okay. So you just need to understand this. You write this equation, London equation, and the solution for this you have to write down this solution. You're gonna learn. I think in mathematics you'd have learned it. I don't know. Okay. So here this is the fundamental length of the superconducting state. Okay. I'm going to close that. And you can see how it's penetrating. You can clearly see that it's not sharply. So it's penetrating. It's not completely zero. You should note down all the notes better. Otherwise, you're gonna miss everything. You should keep in the whatever. I think whatever the material is there in the slides, that is enough for your exams. You don't need separate notes. Whatever they directly, you can keep the same points in the exam. Okay. So again, I'm gonna show you a penetration depth and coherence length. So as I mentioned before, London equation, Bx is equal to B naught e power minus x by lambda L, and it is a distance up to which magnetic lines penetrate through the material when you place in the magnetic field. So this is a magnetic field we're placing. So you can see how they penetrate into the superconducting state. This is a superconducting state, but there is a up to certain distance there is a magnetic field. It's completely, it's not type 1 completely zero beta. Type 1, this is completely zero. In type 2, their field lines may penetrate into the sample. It's not completely zero. This is type 2. Okay. So in type 2 superconductor, there is up to some certain distance. Magnetic field lines penetrate through the material. And that is actually penetration depth. If someone asks you what is the penetration depth, it is the depth where the magnetic field lines enter into the superconducting material. That is called penetration depth. Coherence length. Coherence length is the range in the superconductor in which superconducting electron remain in the same state, spatially varying the magnetic field. So its coherence length is the up to certain width, up to certain length, they do not. So where it indicates complete length of the superconducting state. So this is the length. It's completely obey the superconducting properties. So coherence length is the a length where you have the completely material shows the superconducting state. So in this case, rho is completely zero. The region where the length up to which resistivity is zero is called coherence length. The resistivity of superconductor suddenly falls to zero, indicates the electrons and material come to the same state suddenly. And this you have to, what is the, should remember this. So this is the order of this. Order should you should have remember 10 power minus 4 centimeter. Competitive question. Okay. So I'm going to clear it. So now you understand what is the difference between the coherence length and the uh, penetration depth. Penetration depth is the length up to which the magnetic field lines enter into the sample. That is the penetration depth. Coherence length is the length up to which resistivity zero. It's completely superconducting state. And perfect ga unna state ne manamu coherence length ga తీసుకుంటాము. Behind that తర్వాత కూడా length వచ్చేది penetration depth. So the last topic of this, BCS theory. BCS theory. What is the BCS? BCS is a great scientist. BCS theory of superconductivity. What is the B? Borden, Cooper, Schreiber. BCS theory. These three scientists work together and produce this Cooper pairs. We call it Cooper pairs. You guys are really lucky. You are learning the topic now. So this should be actually like, master PhD topic. But I'm not going to depth, I'm just going to touch it. It's a really wonderful topic to understand, but I don't want to make you so tough. This, now what is BCS theory? And BCS theory, so come on. So BCS theory is the one, basically, it explains completely microscopic origin of superconductivity. So it helps to explain the 4 marks question compulsory. It explains the microscopic origin of superconductivity. BCS theory is the theory which explains what it explains. Swapna, what did it explain? Microscopic origin of superconductivity, right? What is the importance of BCS theory? It explains the macroscopic origin of superconductivity. What it also explains? It also explains the mean field theory. You're going to understand this later. It also applicable to conventional superconductivity. So mainly what are the reasons to have the superconductivity? So they have explained this with the help of this theory. So, okay. Did I post the attendance?
Yes, sir.
Okay, please finish it, that one. And I don't want, this is already we discussed it. We don't want to this anymore. Type 1 superconductor, we know that suddenly resistivity 0. And type 2, type 1 itself, this is kind of type 2. They alloys, usually type 2 is alloys. They don't show that the sudden drops. I just want to put this. I don't want again repeat, but type 2 already know that it's like, slow. It changes into, it decreases resistivity very slow. And BCSC, as I mentioned, these are the three scientists, great scientists, really wonderful scientists. Broad Cooper, Shippa. Theory of superconductivity explain the origin of superconductivity with a microscopic origin of superconductivity, and with the help of condensation of Cooper pair into the boson-like particles. Cooper pairs means electron. They form a Cooper pairs. At certain, they don't. Basically, you guys know that they are opposite, like negative particle, right? They repel each other. Up to which they repel each other. This is the they form a pairs like this. So with this Cooper pair, we call this is Cooper pairs. Cooper pairs, and this can be possible only at low temperature, very low temperature. So with this only they show the superconductivity. So okay, so what is the, you can also here you can see here, in a condensed matter physics, a Cooper pair, BCS pair, is a pair of electrons. As I mentioned, pair of electrons. Okay, bound together. At kalchipothe, bound together at a low temperature in a certain manner. First who discovered, American physicist Cooper is the scientist, he discovered it, 1956. So at low temperature, electron itself bound together. That is called Cooper pair. Very good. What are a Cooper pair? Really, it's a Cooper pair is the one which is really helpful to understand the superconductivity, and they form at low temperature. Electron, they bounded together at low temperature. That is called Cooper pair. The idea of physics is that the first electron polarizes. How they bond? First electron polarizes by the medium, attracting the positive ion. So the second electron, and these excess positive ions in turn attract the second electron. So this will move to other place, and there is a positive core is created. Another electron comes here, and this electron here negative. So these two are form a bond. Those are called Cooper pairs. So you can see here Cooper pair moving through the lattice. How they moving? So the yellow ones are actually positively charged lattice. Electron come together, but they repel, but they come together, they form a Cooper pairs. Drawbacks. Cooper pair, this theory could not explain the superconductivity of type 2 superconductors. Valid at low temperature only, does not predict which material may be superconductor. So low temperature దగ్గర పనిచేయదు. Low temperature దగ్గర పనిచేయదు beta, and especially it doesn't explain the type 2, and it doesn't also help the which type of material also superconductor. So I don't want to. So the great topic is, next topic is lasers. So most of you, let me see why you guys are moving like why you are leaving actually. I don't know. Sapna is here. Who are there? Sapna? What happened actually? Why you guys are leaving? Tell me. I don't want to. I didn't understand why you guys are leaving. What is the problem? Tell me. I'm gonna stop this sharing, then join back. Tell me what is the problem? Why you are leaving? Sapna joined and she left. Rajeshwari. Only three. Tell me what is the reason you guys are leaving? Huh? No one. You have to speak, right? Tell me. Hmm? So not connected at all. It's not connecting. Some people are saying. Can you share the link? Physics password. Why it's not connecting, Nana? Can you share the link? Do you know how to share the link, please? Ramya saying Zoom link, she is unable to. Hmm? Talk, Sushma, are you there?
Yes, sir.
Can you able to share it, or do I need to share it? Do you know how to share it?
Don't know, sir.
No, there is a link, Nana. Invite under participants. Under participants,
Yes, sir.
there is a invite,
Copy link.
and copy and post in the group. That's it. Did you? Under
Yes,
participant.
sir.
Okay. Send it to the group. I don't know why these guys are. Did you send it?
Yes, sir.
I mean, are you guys are following or not? Tell me. Any doubts?
No, sir.
I mean, I don't know whether you are following. Hmm?
Sir, your voice resound.
Oh, sir. Wait. You didn't post it. I posted just now.
I post in girls group, sir.
Okay, nice. Right. I want to complete this fast. I don't know why you guys are, it's like teaching for only few students. I feel like so bad. Right. Okay, I would say still okay. So any doubts so far? Uh, Gautami, do you have any doubts? I mean, I don't know, you just joined, I guess. Gautami, are you there? Anjappa, are you there?
Yes, sir.
అర్థమవుతుందా? సినిమా చూసినట్టు చూస్తున్నావా? సినిమా అర్థమవుతుంది కనీసం.
ఇప్పుడే జాయిన్ అయినా సార్.
ఇప్పుడే జాయిన్ ఎందుకు?
వర్క్ ఉండే సార్.
ఆ?
వర్క్ ఉండే సార్.
వర్క్ నాన్న, ఇగో సిలబస్ అయిపోయింది, ఆల్మోస్ట్ సూపర్ కనెక్టివ్ అయిపోయింది, లాంగ్ ఆన్సర్ అన్నీ అయిపోయినాయి. లాస్ట్ టాపిక్ ఉంది, ఆప్టిక్స్ లేజర్స్. అదొక 3 క్లాసుల్లో క్లోజ్. ఈ వీక్లో క్లోజ్ చేసేస్తున్నాను ఇంకా అంతే. నెక్స్ట్ 3 days ఐఎమ్ గోయింగ్ టు క్లోజ్ ఇట్. మీరేం వర్క్ ఉందని జాయిన్ అవ్వట్లేదు. సాయినాథ్ మళ్ళీ వెళ్ళిపోతున్నవారు. టెల్ మీ
సార్.
టెల్ మీ, అర్థమవుతుందా? ఏంటి ప్రాబ్లం? ఏంటి జాయిన్ అవ్వట్లేవా?
అర్థమవుతుంది సార్.
ఫేర్గా చెప్పండి, నాకు భయపడిన అవసరం లేదు బిడ్డ. ఐఎమ్ వెరీ ఫ్రెండ్లీ. యూ కెన్ ఐ నో దట్. అంటే మీ లెవెల్ అంత లేకపోవచ్చు మేబీ. స్టిల్ నేను కొంచెం ట్రై చేస్తున్నాను, ఎందుకంటే ఇది డెఫినెట్గా హై కోర్స్, వెరీ వెరీ అంటే హైలీ ఎంఎస్సి పిహెచ్డి పిల్లల కోర్స్ ఇది. అయినప్పుడు కూడా ఐ వాజ్ టీచింగ్ లైక్ ఏ వెరీ లో, అంటే అంత డెప్త్ కూడా వెళ్ళట్లేదు. సో మనకు అంత అంటే బేసిక్స్ చాలు అనుకుంటున్నా కాబట్టి. ఓకే నితీష్, ఆర్ యు దేర్? స్వప్న జాయిన్ అయిందా? స్వప్న జాయిన్ అయ్యి మళ్ళీ అవుతా ఏమంది? స్వప్న, ఆర్ యు దేర్? ఏమైందమ్మా? ఎందుకు జాయిన్ కావాలి ఈరోజు?
జాయిన్ అయినా సార్, కాకపోతే కట్ అయిపోయింది మధ్యలో, మళ్ళీ ఓపెన్ అవ్వట్లేదు.
సో
ఇప్పుడు మళ్ళీ లింక్ నుంచి మళ్ళీ జాయిన్ అయినా సార్.
సూపర్ కనెక్టివిటీ అర్థమవుతుందా?
అర్థమవుతుంది సార్.
అసలు టైప్ 1 టైప్ 2 సూపర్ కనెక్టివిటీ రెసిస్టివిటీ 0 అన్ని ప్రాపర్టీస్ అన్ని అర్థమైనాయా?
అర్థమవుతుంది సార్.
ఎందుకంటే లాంగ్ ఆన్సర్స్ వస్తాయి. లైఫ్ మంచి ఇంట్రెస్ట్ ఉన్న పాయింట్స్. 14 మెంబర్సా 80 మెంబర్స్కి? వెరీ బ్యాడ్, రైట్? ఎవరి లైఫ్ వాళ్ళే మీరే బ్యాడ్ చేసుకుంటారు. ఐ డోంట్ అండర్స్టాండ్. ఐఎమ్ గోయింగ్ టు కంప్లీట్లీ మీకు ఏం లేదు, ల్యాబ్ మొత్తం ఫెయిల్ చేసి పడేస్తా. ల్యాబ్లో కంప్లీట్లీ ఫెయిల్ చేసి పడేస్తాం. అందరికి జస్ట్ మినిమం 9 మార్క్స్ అంతే, 10 మార్క్స్. వెరీ బ్యాడ్.
సార్,
yes, tell me, సుష్మా.
ఆఫ్లైన్ క్లాసులు ఉన్నప్పుడు కూడా 30-40 మెంబర్సే వచ్చేది సార్ మాక్సిమం క్లాస్కి.
ఓకే,
అంతకంటే ఎక్కువ ఎవరు రారు సార్ కాలేజ్కి కూడా.
మరి కనీసం మనకు ఒక్కో రోజు 37 దాకా వెళ్ళింది, మళ్ళీ ఎందుకు డౌన్ అవుతుంది ఇది? అంటే అలా ఇంట్రెస్ట్ పోవద్దు కదా నాన్న.
అది వాళ్ళ ఇంట్రెస్ట్ సార్.
కనీసం నిన్నటి దాకా 27 దాకా వచ్చేవారు, 27-30 దాకా కనీసం 14కి వచ్చేస్తుంది. ఏమో లాస్ట్ టాపిక్ కదా, కంప్లీట్ చేద్దాం 3 daysలో, అందరికీ బెనిఫిట్ అవుతుంది లాంగ్ ఆన్సర్ అనుకుంటే ఏముంది, యూజ్ లేకుండా అవుతుంది. అసలు నాకైతే అస్సలు అంటే ఇలా ఎప్పుడు ఉండదు. వేరెవర్ ఐ టీచ్ డెఫినెట్లీ అసలు క్లాస్ కావాలని వచ్చేటోళ్ళు ఉంటారు. సరేనే, జాయిన్ అవ్వటట్టు కూడా లేరు. ఇంక మనం నెక్స్ట్ లేజర్ కొత్త టాపిక్ కదా, సో వెళ్దాం. ఇంకా లేజర్ టాపిక్ ఒక 3 days పడుతుంది. ఈరోజు కొంచెం సో కెన్ ఐ స్టార్ట్ ఇట్? వాట్ యూ థింక్? ఇవాళ లేదు కదా తిరుమల సార్, క్లాస్ లేదు కదా?
లేదు సార్.
అందుకనే ఇలా 2 hour క్లాస్ చెప్తావు. 2 hours గర్ల్స్ అందరు వచ్చిరమ్మా, బాయ్స్ రాలేదు. ఓకే, నాకు టైం వేస్ట్ చేసుకోవాలి, ఇప్పటికి ఎక్కువైంది. సరే, ఐ విల్ గో ఫర్ ద క్లాస్. ఓకే అమ్మా, దట్స్ వెరీ థ్యాంక్ యూ. సో లెట్స్ అట్లీస్ట్ షోయింగ్ ఇంట్రెస్ట్. ఇట్స్ నాట్ మై ఫాల్ట్. I don't know why you guys are doing like that. But anyway, it's a very, very, very interesting topic. Especially, everybody is very interested about this laser. So, what is everybody knows that what is laser? Does anyone know the abbreviation of laser? So you can see here, so light amplification by a stimulated emission of radiation. Remember this is also GK question. So most of the questions they'll ask, which of the following is correct? Laser. Light amplification means more. Stimulated means more energetic. Emission coming out, radiation waves. So light amplification by how light amplify? By stimulated emission of radiation. So light can be amplified by stimulated emission of radiation. So this is very important to know that. Then what I am going to teach here, this last topic is absorption. So absorption, spontaneous emission, stimulated emission, population inversion, optical pumping. So out of this, one more essay, long answer. So choice, superconductivity or this one. What choice will be there? Alternate. One LAQ should be from superconductivity or this. So that so whichever option you can take it. But this is also very interesting. So how do you, like, what is absorption? What is spontaneous emission? What is stimulated emission? Population inversion, optical. Within the topic itself, you can understand absorption. So some material is absorbing the light, right? That is called absorption. Spontaneous emission. Suppose when the material is absorbed by the light padinది అనుకోండి ఒక దాని మీద, immediately there is an emission of photons. Okay, so that is actually spontaneous emission. Stimulated emission is a kind of like, I'm going to teach this later. Stimulation means you are giving some kind of external force. That is called stimulated force. Okay. So I'm going to, what is the inversion is complete inverting the system. Optical pump is one of the important quantity which is pumping. So I'm going to teach all this concept now. Okay. So let me move to the very important topics. Light, basically we need to know. Without light we cannot exist. So you have to understand this. What is light? So objective of this is laser light. What is a laser light? What is the importance of laser light as a coherence light? Highly intensity, highly directionality, highly monochrome. With this properties only, laser play very important role. లేజర్ ఎందుకు, లేజర్ వల్ల మనకు చాలా ఇంపార్టెంట్ బెట. ఎందుకు అంటే దాని కోహరెన్సీ ఉంటుంది, హై ఇంటెన్సిటీ, బాగా ఎక్కువ ఇంటెన్సిటీ ఉంటుంది, హైట్ ఎక్కువ దూరం వెళ్తుంది. దొంగలను పట్టుకోవడానికి కూడా వాడతాం. ఈవెన్ బర్డ్స్ ఇఫ్ యూ వాంట్ టు ఐడెంటిఫై సంథింగ్. ఐ మీన్ హై మోనోక్రోమాటిక్ అంటే లాంబ్డా సింగిల్ వేవ్ లెంత్ ఉంటుంది, సింగిల్ వేవ్ లెంత్. సో దీస్ 4 ప్రాపర్టీస్ makes the laser to be unique in the research field, which can be used to get that optical properties of material. So laser light is highly powerful. It is capable of propagating over a long distance and it is not easily absorbed by water. See, very, very important properties. These you have to remember, Nana. What are the basic properties of laser? High coherence, sir. Coherence is matching, Nana. Vibrating same particles. High intensity, of course you know the red laser, blue laser, lot of lasers are there. High direct, long distance ki veltundi. High monochromatic means single wavelength toni, single frequency toni vibrate avutundi. Okay, so laser is a really powerful. I mean, what are the differences between the normal light and laser light? Normal light you don't have this. Laser light you have this. Normal light can go for all direction. Light emit in all direction. No high intensity, no high directionality, no monochrome. All wavelengths are possible. Normal light, white light, anni wave GR untundi. వేవ్ జిఆర్ కంప్లీట్గా ఉంటుంది. ఓకే, సో నౌ యూ అండర్స్టాండ్ వాట్ ఆర్ ద డిఫరెన్సెస్ బిట్వీన్ ద నార్మల్ లైట్ అండ్ laser light. Is it clear, students? Do you understand now what are the differences between the normal light and laser light? Yeah,
Yes, sir.
normal light ki undavu, laser light ki untayi. That is the basic difference. Normal light can emit all direction lo light vastundi, but laser light single direction lo velutundi. High intensity ఉంటుంది ఎక్కువ. If you focus the laser light into your eyes you can damage it completely. If you focus laser light in the paper get fire, like completely it burn. So high directionality, you can use the laser light to focus, to identify, to track the any small animals. So it has also single wavelength frequency. That is the difference, beta. Should remember that. I'm going to ask tomorrow. Absorption. What is absorption, beta? What is absorption? I told you. So this is the E1 and E2 state, beta. E1 and E2. So energy, the E1 energy level, E2 energy level. Okay. This is called ground state, Nana. Ground state. This is called excited state. Excited అంటే చాలా ఎక్సైట్ అయిపోయినాను సార్. ఐ గాట్ ఎ ఫస్ట్ ర్యాంక్ ఇన్ ద ఉస్మాన్ యూనివర్సిటీ సార్. ఐ గాట్ ఎ ఫస్ట్ ర్యాంక్ ఇన్ ద ఆల్ ఇండియా లెవెల్ ఐఐటి సార్, సెంట్రల్ యూనివర్సిటీ సార్. That you excited means your entire genes or your whatever the blood cells, everything you excite like anything. Entire body become like so happy, right? How you become happy? Because your hormones, everything excited. They move into high energy level. So that is called excited state. This is the ground state. So ground state, always like, electrons are there. But how do we go excited state? You have to use the light. ఇప్పుడు గ్రౌండ్ స్టేట్లో మీరున్నారు నాన్న. ఇప్పుడు నేను వచ్చి ఏం చేసా, ఒరే నాన్న మీరు సైంటిస్టులు అవుతారు, అది అవుతారు, మీరు బాగా చదవండి అని మోటివేషన్ చేస్తున్నా. సో దాట్ ఈస్ లైక్ లైట్. ఐఎమ్ ఇండ్యూసింగ్ యూ. అంటే I'm just acting like inducing. Here light also what it does is you are applying the light on the material. So some kind of gold, silver material తీసుకొని దాని మీద లైట్ పడేస్తే ఏమవుతుంది, దాంట్లో ఉన్న ఎలక్ట్రాన్లకు ఎనర్జీ వచ్చి హై ఎనర్జీ లెవెల్కి వెళ్ళిపోయి మనకు ఒక కైండ్ ఆఫ్ లైక్ లేజర్ లైట్ వస్తుంది, ఎమిషన్ ఆఫ్ ఫోటాన్స్ వస్తాయి. సో అలాగే గ్రౌండ్ లెవెల్లో నుంచి మనం ఎట్లయితే ఎక్సైట్ అవుతామో ఏదైనా చెప్పినప్పుడు, అలాగే when you use the light, when you apply the light on any material, within the material electron get excited and move to the higher energy level. This is called excited state, and this is also called absorption of light. అంటే మెటీరియల్ ఏమవుతుంది, అబ్జార్బ్ చేసుకుంటుంది లైట్ ని. Material what it does, so when light can fall on the material, any material, it just takes it and get electrons excited into higher energy level. So that is actually what you call it, absorption process. What is call it, absorption process. So E1 is ground state, E2 is excited state. Now you understand this. Then moving into, I'm going to the another state is called, so what is absorption state? I'm going to discuss here a little bit. According to the Bohr's law, atomic system, what happened? Discrete energy levels, E1, E2 అని వచ్చింది కదా మనకు. When atom absorbs the light or release the energy, what it does, when an atom takes the light, it go into a higher energy and it comes to the back to the ground state by emission. అంటే అబ్జార్బ్ చేసినప్పుడేమో పైకి వెళ్తుంది, ఓకే, రిలీజ్ చేసినప్పుడేమో కిందికి వస్తుంది. సో వెన్ ఎలక్ట్రాన్ జంప్స్ ఫ్రమ్ ద లోవర్ ఎనర్జీ లెవెల్ టు ది హయ్యర్ ఎనర్జీ లెవెల్, E1 and E2, ఇట్ అబ్జార్ప్షన్ అంటారు ఇది. వెన్ ఇట్ రిలీజెస్ అ ఫోటాన్, అంటే లైట్ వస్తే, లైట్ ఫోటాన్ వస్తే, దిస్ ఈజ్ కాల్డ్ ఎమిషన్ అంటారు. ఓకే, సో హియర్ when atom absorb or release energy, it transmit upward or downward. So lower energy level E1 ground state, higher energy level excited state E2. So that difference can give the E2 minus E2. This is Bohr's atomic model which was. So H nu is equal to E2 minus E1. So when it jumps from the ground state to higher energy, it absorbs energy. When it fall from higher energy to lower energy, it emits the photon. That is called H nu. The rate of absorption depends on the number of atoms. How much absorption is there? That depends upon the number of atoms present in the E1. Spectral energy density UF. So, మనకి ఇక్కడ ఇంపార్టెంట్ పాయింట్ గుర్తుంచుకోవాలి బేటా. దిస్ ఈజ్ అ వెరీ ఇంపార్టెంట్ ఈక్వేషన్. ఓకే, సో వాట్ ఈస్ దిస్? సో P12 is B12 N1 UF. We use this one for to get the Einstein coefficients. Einstein coefficient probability is equal to 1 to 2. అంటే ఎలక్ట్రాన్స్ గ్రౌండ్ స్టేట్ నుంచి excited state లోకి వెళ్తున్నాయి. In that case, it is directly proportional to the number of atom present in the ground state, okay, and the density UF, and B12 is the proportional constant. So P12 actually like this. So proportional B12 అని రాస్తున్నాం ఎందుకంటే 1 నుంచి 2 కాబట్టి. Okay, so this is the one of the equation you have to understand. So now you understand, right? Absorption means you get this equation. Absorption means, note down this. Absorption, whenever absorption is there, you get this equation. So now what is going on? Emission beta, spontaneous emission. So spontaneous, now absorption is over. So absorption means it took the photons, right? Absorption means it took the, someone can add the Mohan. So absorption is over. When it's coming back to the ground state, it emits the proton. So that is called spontaneous emission. So these diagrams you have to apply. Absorption means you have to show like this, upward. Emission means you have to show downwards. Okay, so basically E2, E1. Okay, so absorption means E2, it takes it. Emission means it gives out. Ground state, excited state. E is equal to H nu E2 minus E1. This is the equation. So this is the emission equation. Okay, so now two things are over. Absorption is over, emission is over. What is there next? About we have to do the equation also. Emission also, there is a equation. Spontaneous emission. Should write down. System having the atom in excited state. And E2 నుంచి వస్తే కిందికి కాబట్టి E2, E1 goes to the downward. And transition from the E2 నుంచి E1 వస్తుంది. There is a transition from the higher energy level to the lower energy level. So in that case, H nu, HF అంటారు లేకపోతే H nu is equal to E1 minus E2. E1 minus E2. So reverse. Previous case ఏమో E2 minus E1. Here E1 minus E2. Emission is a random. This emission is random process. There is no specific. So if not in the same phase, become incoherent. There is no coherent. So that transition depends on the atom in the excited state. So ఇక్కడ ఏం రాస్తాము? P12 spontaneous directly proportional to N2. N2 అంటే number of atoms in the excited state. Before equation ఏమొచ్చాయి? Number of atoms present in the ground state. So P12 is equal to A21 N2. You should write it. So very important, long answer this. So last time they asked spontaneous absorption stimulated and get the equation for the Einstein. So now you understand here, we completed, see, A21 Einstein coefficient for spontaneous emission. We get the incoherent radiation forms heat by light amplification of radiation by spontaneous emission. So now we understand absorption valla manaku okoti equation vachindi, emission valla inkokoti vachindi. Absorption valla whatever we got it is P12 is directly proportional to the number of atoms present in the ground state N1, density rho. So B21 we wrote there, B12 here A21. So a spontaneous emission comes from the higher energy level to the ground level. So that is called A21 we kept. Emission means. N2 is the number of atoms present in the excited state. That's okay. So after this, stimulated emission. So now it's very interesting. So now we completed absorption is over. Spontaneous emission is over. Now stimulated. Stimulus ante telusa meeku? Stimulated ante endi? What is the meaning of stimulated ante manamu excite chestam, stimulate chestam oka atom ante you are giving more ante okati iste rendu vastayi chudandi. Stimulated emission, that is gone. So you are applying some kind of radiation, there is a stimulated and the ground state when it's coming from the E2 to E1, your 2 photons are coming. See, 2 photons are coming. For 1 photon, you are getting 2 photons. That is called stimulated emission. Okay. And what is this? So the third equation we are going to get it here. So third equation. So you know this here. So stimulated having the atom in excited state, that's correct. Okay. Goes to the down. Same stimulated spontaneous emission ante endante they definitely go from the E2 level nunchi E1 level ke vastayi. Both stimulated aina rendu S'lu kuda spontaneous stimulated emission, both are actually helps the atoms to come from the higher energy level to the lower energy level. Okay, and that you have getting 2, right? 2H nu is equal to E1 minus E2, right? And emission depends on the energy density, as I mentioned it. Again stimulated emission also P12 is directly proportional to N2, number of atoms present in the excited state, density UF. The total is B21 N2 UF. So this is the third equation. We got 3 equations. One is absorption P12. Then what we got it? P21. Then P12. So this is absorption. This is spontaneous. This is stimulated. Okay. Here B12, A21, A12, and here B21. So these two are completely opposite. Okay. So again, this is the Einstein coefficient, and there's one photon of energy H nu or HF stimulated 2 photon of energy. ఒకటి పంపిస్తే రెండు వస్తున్నాయి చూడండి. This is called stimulated energy, stimulated process. Okay, stimulated emission. So what is the difference between the stimulated emission and spontaneous emission? In spontaneous emission, for 1 electron you have 1 photon. For 1 photon, again you are getting 1 photon emission only, right? Whereas as stimulated emission, for 1 photon energy, you are getting 2 photon energy. That is what greatness. Okay. So very nice. Up to here, you are almost like one essay is also over. So that is 3 gives the Einstein relations, and put population inversion I'm going to teach tomorrow. Optical pumping also I'm going to teach tomorrow. And Einstein coefficient, whatever we discussed just now, I'm going to explain tomorrow equations. That's over. After this, lasers. It may take 2 more days for lasers. So hardly 3 classes. After today, I'm going to take 3 more classes. Okay. So 3 more classes. Now you can fill the attendance, I think, over, right? Or maybe some people, if you miss it, you can Do it again. Any doubt, Nana? Swapna, Sushma, Rajeshwari, Linganayak, you are not attending regularly.
Sir.
Sir, attending, sir.
But not so. I guess if I ask question, are you able to answer it? Superconducting మొత్తం చెప్పాలని చెప్పగలుగుతావా?
No, sir.
మరి ఎట్లా? So you have to be regular, learn properly, attend classes, just go through my notes, whatever you have completed. I mean, just go through the YouTube link. You want to listen it again. Keep effort. Attending,
Okay, sir.
Okay. So
Okay, sir.
we have 3 more classes to finish it. We have 3 more classes to complete it. Okay. Is it clear?
Okay, sir.
So after that, what
Yeah.
I'm going to do, I'm going to take next week 2 or 3 classes, lab classes. Okay. You have to write down the records. I'm going to teach 4 experiments. You have to write down the records. If you don't, write the record, I'm not going to give the marks for that. Okay.
Records notes, sir.
Yeah, records fill cheyala. Records ki 4 experiment chepse 4 experiment records pettandi.
Sir.
Physics ku 2 records unde. Oka record emo aa paper ki
Notes istara, sir.
records notes నేను ఆన్లైన్ చెప్తాగా క్లాస్.
Okay, sir.
అవి సేమ్ పవర్ పాయింట్ ప్రెజెంటేషన్ లోనే ఎక్స్ప్లెయిన్ చేస్తాను, వినాలే, రాయాలా ఓన్గా.
సరే సార్.
కాపీ పేస్ట్లు మర్చిపోవాలా. యూ హ్యావ్ టు అండర్స్టాండ్, రైట్, లిసన్ ట్వైస్, రైట్ యువర్ నోట్స్. ఓకే.
Okay, sir.
So I mean, I have already completed 2 experiments. BH experiment is over. RH experiment, that Hall effect coefficient is also over. 2 experiments already over. Okay. I'll revise again, and 2 more experiments I'll focus it. Okay. So ask your friends to join last few classes. Last 3 plus lab 3. 6 classes are there. Almost 6 more classes. I'm going to complete it. Okay. Right.
Okay, sir.
Right. All the best. Thank you. I'll be at college. If you want to visit college, you can come and I'll guide what you want to do for the exams. Thank you.
Okay.
Right.